Assalamu alaikum wa rahmatullah. Today, inshallah, we're going to talk about factorization by grouping. To factorize the four terms expression, we have two methods to do it. The first one is to try to group it into two binomials. By binomial, we mean an expression consists of two terms. So let's try to factorize the following expression. To decide which two terms can form a binomial, we take a look at the first one and try to find a term that has a common factor with it. As you can see, 3b and xa has nothing in common. So we're going to take 3b and 3a to make the first binomial. Using the commutation property, we can rewrite this to become 3b plus 3a plus xa plus xb. By taking the first two to make the first binomial and the last two to make the second binomial, we can see that 3b plus 3a has a common factor which is 3. So we can divide each term by 3. You will have b plus a. So we can rewrite it as 3 multiplied by b plus a. Looking at the second binomial, we find out that the common factor is x. So you divide each term by x, you will get a plus b. And we rewrite it as x multiplied by a plus b. From commutative property, you know that b plus a is the same as a plus b, which means it's a common factor. I can divide each term by it. You will have left 3 plus x. And the final factorization will be a plus b multiplied by 3 plus x. And we cannot factorize any of these any further. By taking a second look to this example, we can see that the first term and the last term also has a common factor. So we could have regrouped it in a different way. So using again commutation to rewrite this, I can get 3b and xb together and xa with 3a together. Our first binomial 3b plus xb has a common factor which is b. So I can divide each term by b and rewrite this to become b multiplied by 3 plus x. If you look at the second binomial, which is xa plus 3a, the common factor is a. So I divide each term here by a to get x plus 3. And we write this as a multiplied by x plus 3. Of course, you know that 3 plus x is the same as x plus 3, which is a common factor in this line. So I can divide each term by x plus 3 to get b plus a. And rewrite this as two factors, 3 plus x multiplied by b plus a, also the same as the previous answer we got before. We cannot factorize anymore. Also in this example, we can factorize it by grouping it into two binomials. If I take a look at the first two terms, I can see they have a common factor which is 4. So I will take the first two to become my first binomial, which are divisible by 4, to get x minus 7. So I can write this to be 4 multiplied by x minus 7. However, the second binomial has a common factor which is a. So by dividing each term by a, you will get x minus 7 also. And we write this as a multiplied by x minus 7. The common factor, as you can see here, is x minus 7, so I can divide both terms by it. When we divide each term by x minus 7, you will have 4 plus a. So you can factorize it into these two factors, which can never be factorized any further. In the following expression, the first two terms has a common factor which is x squared. However, the third term has the negative sign. So you have to put it inside of the bracket and put a plus sign between the two binomials. So the first binomial will be x cubed minus x squared, and it has a common factor as we said, which is x squared. By dividing each term, you will get x squared multiplied by x minus 1. To get rid of this negative in front of the 9, we're going to take negative 9 as the common factor. Then we will divide each term by it to get x and negative 1. Then we can write this as negative 9 multiplied by x minus 1. As you can see here, we have changed the sign because we are dividing by a negative number. X squared is multiplied by x minus 1 and negative 9 is multiplied by x minus 1. So obviously x minus 1 is the common factor which we're going to divide by. However, the two factors here, one of them is a difference between two squares, so we can factorize it again into x minus 3 and x plus 3 to get the final three factors which can never be factorized anymore.